All right, so today we're going to start talking about phase changes, and our main questions is how does matter change form, and how can a scientist tell what type of change occurs in a substance? So there's three different phases of matter, and those are solid, liquid, and gas, and transitioning from each one is called a phase change. So when you look at what those molecules look like when they're in either of these phases, you'll notice that the solids are tightly compact, but these are still vibrating in place, but they do take a true shape. And then the liquid conforms to whatever shape the container is, and they are moving around. They have a lot more energy, but are still tightly packed. And then the gas are freely moving, bouncing off the walls, no set volume unless confined to a volume, and have a lot more energy than both the solid, the liquid, and the liquid. So as you move from a solid to a gas, more energy is released. So solid, like we said, has a definite shape and volume, and the atoms vibrate in place. The liquid has a definite volume, but it can take the shape of its container. These atoms are moving around freely. And the gas has no definite volume or shape, and the atoms are really far apart, and they're moving very quickly. So there's a couple of things that we call phase transitions, and this is exactly when the energy sources or energy forces the atom to change state. So there's something we call melting, which you all have heard of, which is when we go from a solid to a liquid. So think of ice melting. Evaporation is liquid to gas. So this is going straight from a liquid into a gas form, evaporation. You can also think of boiling water. Condensation is when you go from a gas to a liquid. And you'll notice on the outside of bottles that are cooler, that cool container, because it cools just like in the clouds when things cool, it forms these water droplets. As the water condenses, it's already in the air. So gas to liquid is condensation. And then, of course, freezing is liquid to solid. And you can just think of freezing some ice or freezing some water into ice cubes. So if we look at something called a phase graph, at 0 degrees, ice melts. And this is what we call the freezing point. And at 100 degrees, water boils, and this is what we call the boiling point. So at 0 degrees is the freezing point, and 100 degrees is the boiling point. Any of the flat lines you see in a phase change graph, which I'll show you in a second, mean that all the atoms have to wait before changing states. So let's look at this graph right here. We go from a solid to a liquid, and we notice that it melts. Energy is added in the form of heat. And then as you go from a liquid and you want to get to a gas, you have this flat line that it was talking about. And those flat lines are that time when it's waiting for everything to get from a liquid to a gas. Once that line increases again, then you know all of the molecules are in the gas form. But look for these keywords like condenses, boils, freezes, and melts. This also shows you on here, besides the temperature going up the side, if we're cooling or if we're warming up in an area. Let's get that last slide. Sorry, guys, having a little bit of a computer issue. Okay, so the atoms and the molecules, no matter what phase, are always in motion. And the amount of motion is really dependent upon the state of matter. So we talked about the solid having the least kinetic energy, and they're just vibrating in place while in a certain form. The liquid has even more kinetic energy than that, and the molecules are moving around. And then the gas has the most amount, where the atoms and the molecules are moving around very quickly. Today in your packet, You're going to be drawing a phase change graph like you just saw, as well as the actual phases of matter. Check the back of your periodic table for some help with these things. And once you're done, move on to your exit ticket online.